Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from Group 7 with our title Computer Graphic in Linear Algebra. Linear algebra is a branch of mathematics concerned with the vector space that are frequently finite or countable infinite in dimension. Linear algebra has application in computer graphic. Graphic are any sketch, drawing, or special network that graphically represent some meaningful information. Computer graphic is used when a set of images need to be manipulated or when an image is created in the form of pixel and is drawn on a computer. Computer graphic can be used in digital photography, film, entertainment, electronic gadgets, and video games, as well as all other course technology. Is it a broad subject and area of computer science? In the video game industry, two three-dimensions are required in computer graphics, which you can create using matrices and vectors. It is interested in the entire process of creating computer-generated imagery, from creating digital three-dimensional models to texturing, rendering, and lightening those models, digitally displaying those renderings on the screen. This procedure begins with a simple object rendering technique that converts mathematical representation of three-dimensional objects into a two-dimensional screen image, calculating projection, transformation of vertices as well as object occlusion and depth.
So now I will explain about the methodology. So methodology in the computer graphic, metrics are used to represent many different types of data. Game that involve 2D or 3D graphic rely on some metric operation to display the game environment and character in game. Here we suggest one of the methods modified by the outcome of our knowledge from linear algebra. The method that we use firstly is metric of verticals. In a computer graphic, an object can be constructed using a setup of the point or vertices. Second, metric multiplication. This basic triangular shape can now metric multiplication allows us to perform transformation on our object. This can be performed by using the row-column rule for computing app. Third is from 2D to 3D. In order to make the move to three-dimensional space, we need to use mathematical concept. So, in computer graphic, we use transformation. In three dimension, rotation and scaling can be represented as a multiplication of a 3 times 3 metric by a 3 point. Second, we use rotation and translation. In rotation, we rotate the object at a particular angle data from its origin, and for the translation, we move an object to a different position on the screen. For third, reflection. It is a transformation which produces a mirror image of an object. Either the mirror image can be about x-axis or y-axis. The object is rotated by 180 degree. And for scaling, in computer graphics, scaling is a process of modifying or altering the size of object. And lastly is a sharing is a transformation which change the shape of object. The siding of layer of object occur and the share can be in one direction or two direction. Okay, that's all for me. Thank you.
Okay, I will explain you about the translation and rotation. For the first slide is about the translation for the 2D dimension. Okay, what is the translation? Translation is the movement of the any object from one position to the other position. To get the new coordinate, which is the x and y, need to add in translation coordinate, which is a tx and ty to the original coordinate xy. Tx and ty is translation vectors, which is we can write like this, which is a x, the new x equal to the old x plus the ts, and the new y equal to the y plus the ty, and we can use the column vector can represent like this. They have a two option, which is the first one or the second one. So we go to the other slide. This is about the translation for the 3D dimension. So have a three direction, which is a x represented ts, y represented ty and z is represented tz. X, Y, Z is the point coordinates before the transition happened. S1, Y1 and Z1 is the point coordinate after transition happened. 3D dimension transformation are performed by transforming each vertex of the object, and metric can represent like this, which is the right side or the left side. So here is the example question for the transition. Okay, I will explain you about the rotation 2D dimension. Okay, what is the rotation? Angle theta, which is to rotate the object from the origin point, which is a PXY, to the new PXY, using the standard trigonometry. So here is the three step, which is we need to find the origin point, which is a PXY, can show like this by using the equation, and then after that we need to find the new points, which is xy, by using the equation, and after we get the new point, we need to substitute into the origin equation, and we can get the new equation after rotation happen. And then this is the metric form that we can write like this, which is we need to we have the two options, the right or the left side. And then as we know that rotation for the arc can be positive and negative. As we know that 3D rotation is different for the 2D rotation. Also have to define the angle of the rotation with the axis of the rotation. So if the rotation happen to the x, we need to make sure that y and z use the equation, and then for the form of the metric, it show like this. So we go to the other slide. This is about the rotation for the y-axis. If the y-axis happen to rotation, we need to make sure that x and z use the equation, and then for the form metric is like this. If the rotation happen to the z, we have to make sure that y and x use the equation, and then for the form metric like this. And here is the example equation for the rotation, the 3D dimension.
Assalamualaikum warahmatullahi wabarakatuh. So I will continue with another three transformation in 2D and 3D transformation. So we continue with 2D reflection. Reflection is a kind of rotation where the angle of rotation is 180 degree. The reflected object is always formed on the other side of mirror. The size of reflected object is same as the size of original object. This reflection is achieved by using the following reflection equation. So in 2D reflection, we have x-axis and y-axis, and we will get the same equation, but we will get the difference in reflection method with negative and positive number. So we go to 3D reflection, which is have xy plane, yz plane, and xz plane. So this reflection is achieved by using the following reflection equation in metric form. Above reflection equation may be represented. So in 3D reflection, we will get the same equation in xy, yz, and sz, and we will get the difference in 3D reflection metric, which is negative and positive number. So we continue with 2D scaling. Scaling may be used to increase or reduce the size of object. Scaling subject the coordinate point of the original object to change. Scaling factor determine whether the object size is to be increased or reduced. If scaling factor is more than 1, then the object size is increased. If scaling factor is less than 1, then the object size is reduced. This scaling is achieved by using the following scaling equation, and we will get the 2D scaling metric. So in 3D scaling, we consider a point object O has to be scaled in 3D plane. Let we initial coordinate of the object O equal to x all, y all, and z all. Scaling factor for x-axis is sx. Scaling factor for y-axis is sy. Scaling factor for z-axis is sz. New coordinate of the object O after scaling is x new, y new, and z new. This scaling is achieved by using the following scaling equation, and we will get a 3D scaling metric. So we go to 2D shading. Consider a point object O has to be shared in 2D plane. Let initial
Coordinate of the object O equal to x all y all. Sharing parameter towards x direction sh. X sharing parameter towards y direction is sh y new. Coordinate of the object O after sharing is x new and y new. Sharing in x axis is achieved by using the following sharing equation. So in 2D sharing, we only has x axis and y axis, and equation we will get a different equation, and we also get a different sharing metric as I show in the slide. So in 3D sharing, we will use new coordinate of the object O after sharing x new, y new, and z new. So in 3D sharing, we got three axes. Another axis is z axis. So the difference of equation for 3 and the different for 3D, 3D sharing metric. So we got the different equation and different metrics. So that's all from me. Thank you.
In conclusion, linear algebra is used in many different ways in computer graphics. The mathematical structure of a computer graphic takes advantage of many operations and theorems in linear algebra to assist in 2D or 3D models, in animation and in rendering. First, in the modeling of a surface of an object into representation of a collection of points in 3D space. This process is done with the help of a modeling software or by using specialist 3D scanner. However, the end result is always a collection of points in 3D space. These points are vectors in linear algebra, on which the process of linear algebra such as a transformation, rotation, and scaling can be applied. Vector graphic is a linear algebra way of storing and manipulating computer image. 2D vector graphic were especially suited to moving, rotation, and scaling image are objects within computer graphic. So that's all from our group. Thank you for your attention and hope you understand about our group assignment.